So I'm going to get started with the presentation. And we're going to talk about sharing critical controls. And I always start all my classes that I teach with the zero harm share. And I'm going to start the zero harm share with one of the most important events in our industry, which was the tailings failure in Brazil. And it's important for a couple reasons. Not only was it large, that it was impactful, 17 people killed, significant environmental damage, and this town destroyed. So those are all big impacts. But the other part of it is also that they did a great job of an investigation and sharing that investigation publicly. And because they did that, they told all of us in the industry some of the issues that caused that to happen. And what actually happened is that there was some slimes that had been put into the dam area, or some of it was caused by some flooding. And as they built the dam, pressure on top of those slimes, and slimes are called slimes for a reason. They are slimes. They are mud. And it got into the dam, and as they built it up, it actually pushed down on those slimes, and it forced those slimes out into the front end of the dam, and the dam actually failed. Now, we as lawyers and safety people may not need to know all the technical aspects of that, but we do need to know the importance of that investigation and sharing that investigation, because that went around the world. And it changed the way that companies looked at and how they inspected their dams from that point on. And so that's kind of what we're talking about today. So I'm going to give another case study in a lot more detail, and that's the Bingham Canyon failure. Now, the reason I talk about the Bingham Canyon failure is they actually brought me into Bingham Canyon 6 weeks before it happened. And I was brought in because they knew it was going to happen. And we needed to make sure we planned for that, and not only plan for it, then recover from it after it happened. So I had probably the opportunity of a lifetime to actually be a part of an amazing experience. And it was amazing because of one reason: nobody died. So this happened in 2013. The failure actually happened on April 10th. On February 12th of 2013, the geotechnical engineers came to the management of the company. They said, "We've got a problem." They showed them this slide, and what this slide shows is that if it's in yellow, the areas that are in yellow means that the land or the high wall is moving. Now, high walls always move. That's just a part of mining. But what you look for is when it starts to accelerate. And the yellow said that this area to the top was moving faster than the area to the bottom, which is white. So the darker the color, the faster the movement. Now, the movement was really small. It was actually almost the size of the movement that you would normally expect. But this is a huge area, much larger than they've ever seen for any failure in the past. And what they said is that we could have a failure that's going to be much larger, orders of magnitude larger than anything we've ever seen. And this is a mine that's had hundreds, if not thousands, of landslides. So that's a big deal. So because they had that forewarning, they were able to start planning and preparing for that. So on April 10th, this is what the high wall looked like in the morning. They had gone through a lot of planning, and they knew that failure was going to happen in hours to days. That night of April 10th, the failure occurred. And what happened was the largest landslide in mining history. 144 million tons literally exploded out of the high wall in 2 different events. And it acted way differently than we ever expected. So normally what you expect in a high wall failure is that in a matter of hours or days, the material will actually start to slide down, it will come to a rest, and it'll go to an angle of repose and stop. And when that happens, you start your work. You go back to work, you find a way to solve that problem, and you fix it. And that's what we expected. That was based on at 106 years of experience in mining high wall failures. We were as experienced in predicting and understanding and repairing those types of failures as any company in the world. We were the experts. But this one did not act like we'd seen before. Instead of hours or days, in 90 seconds, that material exploded out of the high wall and it flowed like water down to the bottom of the pit. It traveled 1.5 miles in those 90 seconds. And then an hour and a half later it happened again, and at the same thing. Half the material, half of that 144 million tons of material exploded, went down in 90 seconds to the bottom of the pit and covered the bottom of the pit. We did not expect that. We expected that failure to act like all the failures that we'd had in the past. Now, to show you how extensive it was, now think about gravity. Gravity wants to take things and send it straight down. Now, 144 million tons of materials is a gigantic volume of material. It did not flow down. What we would have expected is after it failed, it would have fell straight down into the pit. What it did is it shot to this side. It actually hits this wall and it slides down the wall airborne for 3/4 of a mile. That's amazing. The energy to do that, if you calculate the potential energy for that, is like 6 Hiroshima bombs. Unbelievable. We did not expect that. So this is what we expected. This red area is what we expected a normal landslide would impact us. This is what happened. This is the area that it impacted. And because of that, we had prepared for the failure to get back into operations as quickly as possible. We knew that the main haul road would disappear, at least a significant portion of it. So we stationed equipment down in the pit to be prepared for that. This is called the Molly Dome. This is an area down in the bottom of the pit that didn't have much copper, but it had more moly. And so we didn't mind that for a number of years. This is 300 foot high. We thought at the very worst case, the failure would come from this side, it would come to the toe of this, and it would stop, it would build up to an angle of repose, and then we could get back to work. And so we prepared for that expectation. This is what happened. That's the same picture. We not only covered up the 300 foot to the Molly Dome, we put 300 foot of material on top of it. And so all of our preparations, or many of our preparations to get back to work, were for naught. This is what we had done to prepare. The failure is going to come from this side, ultimately. And what you see here, you see this black string. We knew we could get back to work because we had an in-pit crusher, and so we stationed parts and supplies and equipment down in the bottom of the pit. Now remember, this is 300 foot above the bottom of the pit. So when people say, well, why did you park equipment down the bottom of the pit? The answer is we didn't. We put the equipment 300 foot up. And so these are haul truck tires. There's 75 haul truck tires, and if anybody's bought a haul truck tire around here, you'll know they cost between $50,000 and $75,000 a piece. These are haul trucks. We had 13 haul trucks at in the top of the Molly Dome. They were either destroyed or severely damaged. We had 2 shovels in the bottom area behind the Molly Dome that was supposed to protect us. They also got covered up. So these are the haul trucks. These are 320-ton haul trucks. Some of them are loaded, meaning that total weight was about 600 tons. That failure came through. It was actually moving at an average of 60 miles an hour. That it acted like these trucks acted like wood on the ocean. It just picked them up and pushed them aside. Unbelievable. The force was unbelievable. This is a haul truck that only the front part of it got engulfed. We repaired that truck, by the way. This is a 4100 shovel, one of the largest shovels that we use today, mining shovels. This area right here are 2 drills that was sitting above the shovel, and that drills were pushed right into the boom of that shovel. Now, that shovel was placed 1,000 feet away from where we thought the worst case was. The force of this failure was unbelievable and not expected. This is the Bingham shop where we did a lot of our repairs. This is the scarp with the high wall that's left from the failure. Cuts off the backside. We had to demolish that shop. But you know, the question is this a failure, a disaster, or is it a crisis? We had no fatalities. We had no injuries. And so we were also able to get back to work. Not right away, but a lot faster than most anybody ever thought possible. I would say that this is a crisis. This is the point where you have to make decisions, and those decisions can take you different ways. They can lead you to disaster, or you can recover. I think we made a lot of decisions that made it a crisis and not a disaster. Yes, it was impactful. Yes, we had to do lots of work. Yes, it cost lots of money. But we did not kill anybody. So, not long after the failure happened, this is a picture where one of the first times the managers got to go down in the bottom of the pit. I got to tell you, it was one of the scariest things I've ever done. As we came down, there's nothing happening in the pit. We stop and we get out of the van. Now it's difficult getting down the bottom of the pit to begin with. And you're walking around and you can look up and you can see this headscarp, which you know is still potentially unstable. And it's over 1.5 miles away, 3,000 foot above you. And I got to tell you, the hair rose on my arms and the back of my neck. And my first thought is, oh my God, what are we going to do? How are we going to solve this problem? Because it's a huge problem at that point. And so, you know, when you look at it as a whole, it's like, oh, it's so overwhelming. It's where do you start? What do you do? And I had a young engineer, and he was an artist. And what he did is all he did was color code it. And we got this headscarp up here, and it's a huge risk because this is the failure plane that everything failed on, and it's sitting on top of that failure plane, and it could fail. So we have to take care of that. Can we do it? Well, geez, you know, we can't put people out, but if we brought in a remote-controlled equipment and do some things innovatively, yes, we can. We have to fix all these berms and safety benches, which are required and needed for a mine. Can we do that? Yes, we can do that with remote-controlled equipment. We need to put the haul road back in. Can we do that? And so we took the elephant and we put it down into bites that everybody could say, yes, we can do those things. And it made a difference. We had some other things. The green is our ore. In reality, we had ore that we could start mining right away or relatively quickly. Some of it was covered up, and if we didn't get that uncovered quickly enough, we would run out of ore, and it wouldn't really matter. Our downstream concentrator and smelter would be out of business anyway. So we needed to get this area uncovered basically by the end of the year. This happened in April. Now, how many of you saw the pictures after it happened? Anybody? And what was your first thought when you saw those pictures? we're dead. We're out of business. And you know what? Our employees thought that too, to be honest with you. But this is how we got the people to start thinking about it. Actually, we did some other things that helped as well. We did have some available assets. We were not totally out of business. We had trucks available. We had an in-pit crusher and conveyor. The conveyor went underneath the mountain so that if we could get material to that crusher, we could start business once again. We had one shovel left. We used to have 4 down at the bottom of the pit. We had 1 left, and we had 1 loader. And from that into it, we were under a 103K order. And those of you that are in safety around here and a lot of the legal people, you all probably know that a 103K order means that we had to get the federal government to agree to any plan and any change that we wanted to do. Now think about that. You have to get federal approval to go back to work. And every time you do something in that work, you have to get their approval. We also had one way to get into the pit. Our haul road was gone. We had what we call the Keystone Access Way that we actually finished up before the failure happened. And with that Keystone Access Way, it was our only way to get parts, people, and equipment. And a pickup truck had to make a 3-point turn to go around those 13 curves. Unbelievable. But with that, we were able to get started. And in 2.5 days, we were able to start operations at the mine. Now, not down at the bottom of the pit. We didn't start ore operations. We started up at the top of the pit, completely away. And that was the way that we were able to go to MSHA and say, look, we can work safely, out of harm's way, and not put anybody in danger. And with that, we put the plan together and we started working. And the way that we did that, actually, our CEO, our general manager, we were meeting 2 days afterwards. And the general manager was meeting with the managers, and in the middle of the meeting, he said to us, we've got a goal. Our goal is to be in operations at the end of the day. What do you think the manager said? No way. We're in a 103K order. Can't do anything without federal approval. Our employees are in shock. They saw the pictures that you saw a little bit ago. They think we're out of business. They think they're out of a job. We can't even get to their PPE. That's up in a building that we can't get to. We cannot be in operations at the end of the day. And he says, yeah, I know. But, that's our goal. Our goal is to be in operations at the end of the day. And we said, once again, no way. He says, listen, I know. So this is really important. Our CEO, Kelly Sanders, has said this is what we need to really try to do. And we changed at that point. We went from, okay, we can't do this, to what do we need to do to get it done? Now, I actually think we were trying to say, look, here's all the things we've got to do, and we can't get it done. But we started going through it. Can we get a 103K order done? Yeah, we have to have a plan. We have to communicate that. We go through the process. You know what? We didn't make it. Midnight came and went, and we were not in business. 1 o'clock in the morning we were. That could have taken months. But 1 o'clock, and we took no shortcuts. We put nobody at risk. We followed all the procedures. 1 o'clock in the morning, we missed it by an hour. In 2.5 weeks, we were in the bottom of the pit. We were operating. And this is our first load of ore from the bottom of the pit in 2.5 weeks. We did things we never thought we could do. The shovel that we had left is one of our smaller shovels, 2,800, medium-sized shovel. Normal production for that would be about 50,000 tons with the issues of trying to go down the Keystone Access Way. We passed 50,000 tons the first day. We went to 80,000. We were hitting 120,000 tons a day with that shovel. Unbelievable. You can do things that you can never believe you can do if you have everybody working on the same issue and you have the same goal. And that next door, uncovering that next door to keep us in business, our goal was to actually get to that by Thanksgiving, November 24th that year. And we didn't meet that goal either. We actually hit it on November 13th. And so we stayed in business. We never stopped operations for the long period, any long periods at our processing plant. We actually met our production goals for total tons moved for that year. Unbelievable. So this is celebrating success. But you know, we're here today to talk about how do we share some of those things that we did and the critical controls that we put in place, because we didn't hurt anybody. As a matter of fact, for the million hours worked afterwards, we didn't even hardly have a first aid case. So let's talk a little bit about that. How did we keep people from getting killed? Number one is we had, and have even better today, ways of monitoring that high wall. We knew that our number one risk was high wall failures. That was absolutely identified as our number one risk in that mine. And so we had multiple ways of monitoring. We had great training for people to see and to report issues. We had some of the best technology in the world with radar systems. We had not just one radar system, we had two radar systems. And now, after we communicated to the world about what happened and how we actually identified this, those radar systems have exploded. Almost every mine, you know, the number of radar systems that have been sold from this time compared to before has just been exponential. And the technology that's been developed has also been as fast as you could ever believe. We're seeing new systems come out almost on a monthly basis right now. That all starts from communicating a critical control to the entire industry, and it changed the way that our industry works. That's the importance of sharing critical controls. Other things that we did was communications. You know, our communications started before the failure happened. Think about these miners going down into a pit that is 2.5 miles wide and 3/4 of a mile deep. And you've got miners going down there every day. And we have the rule, I think the rule that most of our companies have, that if you do not feel like you're safe, you do not have to do that task. But our miners went down into the pit every day. And part of the reason is because we communicated what the failure was. And the reason why we communicated, I mentioned acceleration is the issue. If it goes faster, then you've got to do something about it. That's when you have to worry about, and if it goes exponential, then the failure's coming. And so we as managers every day wanted to know what the previous day's acceleration was, or what the speed was of the material. Every single day we asked that. And at some point one of us said, well, if we as managers want that information, what about the workforce? Now, the geotechnical engineers, they did a great job of identifying this movement. They didn't really want to share that information. Oh, look, people won't know what that means. They won't know how to handle that. Well, that's wrong. We proved that that's wrong. People understand much better and more than we ever believed. A year afterwards, we had a celebration, 1 year mark from the failure. Celebration wasn't a celebration that we had failure, it was a celebration that we didn't kill anybody. Pretty important thing to celebrate. And the thing that came up during that celebration from our workforce was this, that communications that we had with our workforce. The other critical control is the innovation that was developed. You know, we had to do a lot of work with remote controlled equipment. much more than we've ever done before, and I would say much more than any mine has ever done before. We had to actually create equipment that didn't exist. This is an excavator. It's tearing down this workshop, the shop. That's all being done remote controlled. There's no operator, and we took down that entire structure. And the interesting thing is, before the failure happened, there had never been a remote controlled system on an excavator before. We had to have that developed, installed, implemented, and used, and this structure was taken down by July 4th with equipment that never existed before. So, here's some other things we learned, sometimes the hard way. It's not lessons that a lot of other companies haven't learned, but one of them is having enough data. We didn't have any hydrology holes. We didn't think that water was an issue in that area, but we don't know because we didn't have any holes in that area, hydrology, piezometers in that area. And so we were actually trying to drill some holes when it occurred, when the failure actually occurred. But having enough data, if you're going to look at these large issues, is really important. And I've worked with different companies, and if I see a failing, a lot of times, we don't put enough data for the size of mines. We are mining in totally different conditions than we've ever mined in before. If we don't have the data to do the analysis, we will not find these types of failures. Second one is independent review. We were the best there was in knowing our pit and the failures that we had. Just ask us. We didn't have time to bring in totally independent people to review this. The only way this failure that we had was a totally different mechanism than we've ever seen before. Probably a different mechanism that's ever happened exactly like this in mining. At least that's what we believed. And so the only way you could have predicted that it would have failed the way that it did was to have somebody that looked at things on a different way, because natural failures acted like this before, but never in a mine, where it literally explodes out. And so it's what's called an active-passive failure. And so there are natural failures that are active-passive failures. So if we'd had independent reviews, we don't know if somebody could have told us that, but it was our only chance in reality. And so having that independent review, and the mine now uses an independent group all the time now, and it makes a difference. It's taken our capabilities up a whole nother notch with our geotechnical team by doing that. 3D modeling. So, mines are complex structures. As we get deeper, the geology changes. It's different, the stresses are higher. The only way that you really see this failure is with 3D modeling. We didn't do that. We were really good at 2D modeling. In fact, we predicted failures better than anybody, but we couldn't even see this type of failure with 2D modeling. And geotechnical resources, the people side of this. Our people at the mine were fantastic at monitoring. We did a great job of detecting that this was going to happen. But the fact of the matter is, we didn't predict this type of failure mode, and it really takes a different type of skills. It turns out that geotechnical engineers are not available to the numbers that we need. And so we need more people that are trained as geotechnical engineers for our industry. Because we hire geologists, we hire geological engineers, we hire civil engineers, we hire mining engineers, and we put them into geotechnical jobs. Now, they do a great job. That's not to say that these are bad people and they learn great things, but they don't always have all the understanding that we need. So we not only need to bring in a whole new group of geotechnical engineers training with degrees, we have to do more professional development of the geotechnical engineers that we have in place. Our technology is changing, our methodology is changing, we need to do more. That's part of what I'm actually doing here at the University of Arizona now, the reason why we're creating the Geotechnical Center of Excellence. But you know, one of the important things of this is that Rio Tinto actually shared a lot of things. They allowed me to write a book about it so that the industry, the geotechnical engineers, would learn from a lot of the things that happened. Now that doesn't always happen in our industry. But here, because we've done that and we're sharing that information, we're starting the Geotechnical Center of Excellence here at the university. We also work with the Public Health Department, and we're trying to actually gather critical safety control learnings from the entire industry so that we can share that. So I invite all of you to help with that process. But that's another step along the way, because we as an industry don't always do that. Now think about the Mainfay event. This is a failure that acted differently than we'd ever seen before. It could barely be called a black swan event. They're very rare, you know, these black swan events are things like Fukushima and other events that really change the way that industry works. So, you know, it has to be very rare, has to have lots of impact. For us, it certainly had a lot of impact. Has to be retrospective. Somebody has to, you know, in black swan events, somebody always says, well, you know, why did you do that? You know, the number of times I've been asked, why did you park equipment down at the bottom of the pit? Is a lot, right? Well, first of all, we didn't park equipment down the bottom of the pit, but even if we had, from our experience and knowledge, it shouldn't have mattered. Shouldn't have been a problem. And it's outside the curve. You know, it's so out there that we don't consider it as even a possibility. But you know what? It turns out that there had been another failure that acted like ours. It wasn't the exact same failure mode, but there's another mine a few years before ours that it actually ran out. It had a large failure. It acted in a Volmi type failure, so it acted like an avalanche instead of a landslide. They destroyed equipment, covered up the pit bottom, and they did not communicate that. What if we had known that? What if we as an industry had shared that? You know, we took a risk, or there was a risk, if we had not done what we did with our people to evacuate our people the way that we did, we could have killed a bunch of people. Sharing that type of information and what we learn is critical to our industry if we are really going to make a difference. That's part of what the day is about. How do we do that? So, you know, sharing and providing those critical controls for each other is what's really going to make a difference in our industry. Now, why don't we share? There's going to be talks about this later in much better detail than I'll go through. But from my view, there's really three reasons why people don't share in our industry. And by the way, there's a lot of times we don't share. One of them is liability, and I understand that. These are big dollar items. We have failures that cost billions of dollars today. And we don't want to put ourselves in the position where we're telling information that may put us in a worse position legally. I got that. But there's always got to be a point in time when we should be able to share that information. Secondly, is there's a risk of penalty. You know, There's the stories of the MSHA inspector that goes into the mine site. He sees a picture of an issue up on the board, and they write you up. You know, that's just wrong when you think about it. We're trying to do things to keep people safe, and we get penalized for that. We've got to find some ways to change those things. The other one is reputation and embarrassment. I don't want to tell, you know, my stockholders will not be happy with us because we had a problem. Well, you think the stockholders aren't going to see the results of that sooner or later anyway? I don't want to be the guy that, you know, caused the problem. Ladies and gentlemen, I was the guy that was in charge of planning before the failure happened that covered up 13 trucks, 3 shovels, 3 drills. I was responsible for the planning. Now, I could hide that. You would never know. But we wouldn't change anything. So that reputation makes a difference, and that embarrassment. This is a guy by the name of Everett Hook. He's one of the fathers of geotechnical engineering. And he's put out a number of videos. And one of the things he talks about is rock burst. And so this is deep mines, and mostly in South Africa and India and places like that. Now he is really one of the fathers of our geotechnical industry. So these rock bursts killed many miners. You know, when they explode underground and you're 6,000 feet underground, that's a big deal, right? And so his words is that the industry wouldn't share that information. They would only create these small groups that really limited who could work on it and everything. And because of that, they wouldn't share information across. Because of that, we've never been able to solve that problem. Now, he doesn't say it this way, but you can tell this is a problem that really bothers him. Now, he's making these presentations, giving these talks as kind of his last gift to our industry. And this is one of the things he brings up. And so he's worked on this on and off since 1965. And we still don't share the information. And he said the reason that happens is because we're embarrassed to tell people about the problems that we've had. And I think it's true. And so I have some questions for you today. You're here today, and we're going to talk about sharing critical controls. Now, if we're not going to share this information right away, how do we document it so that at some point somebody can work on it? You know, we as a Geotechnical Center of Excellence are here to actually make a difference and find ways to solve these issues. But we can't do that without great data and understanding of what's already happened. So how do we document it? Number 2, when can we share it? There's got to be a point when this information is available to the greater industry so we can do something about it. Number 3, how can we prevent from being penalized? Now, we can't have the situation where we put in information up on a board or share it with other companies and MSHA or some other regulatory agency says, oh, you've got a problem, we're going to penalize you for that. There's got to be a safe harbor so we don't have that happen. And finally, how do we make safety more important than reputation? We have other industries where people talk about things as soon as they happen. The airline industry is one of them. how can we in mining do the same thing? So, with that, that's the story of the main bay, part of the sharing that we've done, the impact we think that we've had, and what I think some of the things we're here today for.